All right, Ronald, let's get started. Let me give you a quick introduction of myself. So I am Bhupinder. I am the consultant training on Six Sigma. So the biggest certification that I've achieved in Six Sigma is Master Black Belt. And I've worked in different companies, and I do conduct trainings for multinational companies. And I also participate in implementing Six Sigma project across various organizations. Today, the main objective of today's training is going to be completing the green belt level training. I will explain you what a green belt training is. Before that, if you could give me a quick introduction of yourself, and also if you could tell me what is the level are you looking at in implementing a green belt kind of a project, and what is the nature of work that you do, and where do you think this can be implemented?
Okay, sure. So I have about 10 years of experience in supply chain management, ranging, within those elements, ranging from inventory control management to procurement, sourcing, logistics, supply chain, production line feeding, warehousing. So currently my current role is project supply chain manager for a company named Alstom Manufacturing, which we manufacture high-speed passenger trains. And I would like to. I'm a bit familiar with this with some of the content of the green belt of the Six Sigma with the DMAIC methodology. However, I wanted to take a formal course and get some very good understanding of it, and try to apply it from a project management standpoint, from a top level standpoint.
Excellent, Ronald. So I think since you work in a supply chain organization, that on the production side, I'm sure you're very familiar with the DMAIC methodology. And do you have a quality organization as well?
Do I have a what? I'm sorry?
Do you have a quality organization? I mean, do you have Six Sigma folks working in your organization?
Yeah, yes, we do. We do.
Okay.
And we received some, maybe a few years ago, we received some training as well. Some of this green belt methodology, some Six Sigma methodology. And like I said, nonetheless, I wanted to get a formal training and get all the content and get formally certified.
Okay, excellent. So let's get started. So I have a quite fair understanding about your role and your nature of work. I think it will help me moving forward and give you some examples from the inventory or from the supply chain standpoint. Okay.
Sure.
So for the next 4 days of training, or for this week 2 days of training, and the next week 3 days of training, we will mainly cover module 1. We will divide it into 6 modules. The first module would be just to give you an introduction to Six Sigma. We will talk very briefly about the evolution and introduction of Six Sigma, and then we will get on to the DMAIC phase, which has a define, measure, analyze, improve, and the control phase. And how do you do a project closure, right? That's about me. What is Six Sigma? Have you heard anything about Six Sigma? Do you think you'll be able to give me some insight on what Six Sigma is, if you just in a simple one sentence?
Yes, it's a bit more of a kind of a lean manufacturing approach to eliminate unnecessary production and manufacturing or operational waste.
Excellent. Great. So the one key word when we refer to Six Sigma compared to the other improvement methodologies that we have, Six Sigma mainly focus on reducing the variation in a process. Variation is nothing but any product or service that we make. If it calculates how far is it from the target, right? And that's the variation. So basically, if I am looking at an inventory that is getting piled up in your organization. And we wouldn't want to carry any inventory beyond a certain limit, a specification limit that we set. And if at any point of time, if there are inventory which is beyond that particular level, will be considered as a target that is missed, right? And that's the total variation from the central tendency that we calculate. So the key word that you will have to keep in your mind is variation. We also call it a standard deviation, which is nothing but the sigma. All right. So that's a keyword that you need to understand at this level, and we will keep moving forward and explain how a variation is calculated. Just a breakthrough strategy on Six Sigma. This strategy was, the business management strategy was developed by Bill Smith, who's also named as the father of Six Sigma. The Six Sigma was introduced in Motorola in 1981. And it's a pure methodology for continuous improvement. And we use a set of statistical tools in problem solving and out of the box thinking to come up with a solution. So we will explain how a problem can be solved using a Six Sigma methodology going forward, right? And even though the Six Sigma was introduced by Motorola, it was implemented and taken forward to the current level by General Electric, right? And Jack Welch, when he was the CEO of GE, he launched Six Sigma in 1996. And even today, one of the key differentiator for driving efficiencies for General Electric is Six Sigma. And these are some of the key quality pioneers who introduced specific tools that is used in Six Sigma. Some of these slides I will be skipping through because these are some information. I will also share these slides with you probably post the training, and you can go through the details in the. Currently, we will mostly focus on the DMAIC methodology. Any questions from you, Ronald?
No, everything's fine so far. Thank you.
All right, thanks. Okay, so to give you a fair understanding on how Six Sigma works in a business cost model, usually how we determine a price, right? First, we look at the total cost of making or manufacturing a product or delivering a service, and then we'll add a profit margin to the cost, and we come up with a sales price, right? But in the new model, when we use Six Sigma, what we do is we will keep the prices constant, right? And we will minus cost to get the profit. And whenever there's an inflation, we obviously do not go and increase the price. What we look at is we will try and reduce the cost by making the processes much more efficient, thus increasing the profit margin. This is one of the key area where Six Sigma is used, basically reducing the existing cost to drive efficiency and improve margins. So through this approach, what we are looking at is we are providing value to the customer, right? We are not just going and increasing the price of the product because there's an inflation on the materials that we are using. Instead, we are driving efficiencies in the process to ensure we reduce the cost. I'm sure in your organization also, there is a drive that goes through to reduce the cost, right? And this is one of the driving factor in identifying a project within an organization. Okay. Some of the cost of poor quality examples that you have on this particular slide. These terminologies, if you look at waste, right? Rejects, testing cost, a rework, complaint handling. So these are the areas in which we end up spending more than what we are supposed to spend for a company, right? A premium freight cost. excessive overtime, pricing and billing errors. So any rework or any error, any defect, that drives cost, right? So how can you identify a Six Sigma project and how can you drive an efficiency? If you look at some of these examples, you will be able to arrive at it, right? Employee turnover for an HR organization, they can really look at an employee turnover and identify the root causes, and they'll be able to fix it. And every employee turnover goes with the cost, right? And any customer returns, right? If you're managing inventory, any customer returns due to a defect can increase your cost, which is something you can look at. And from the inventory planning standpoint, any planning delays, any excess inventory or incorrect orders shipped, these are all examples that you can actually relate to. Any questions, Ronald, from here?
No, I'm fine, thank you.
Okay. And apart from GE and Motorola, you have some more examples on companies which have successfully implemented Six Sigma. Now, let's look at some of the key functions where Six Sigma can be used. I think in almost all the functions of an organization, Six Sigma is very useful. Production, for example, design, service, purchase, production, in a human resource, administration, quality department itself can drive efficiency in the way they work, in the management and marketing and sales. IT. Six Sigma results. So we wanted to check how far Six Sigma has helped some of these companies in saving costs or improving their revenue. General Electric on each year, right, on an annual saving, they drive efficiencies of worth $2 billion. JP Morgan, for example, they drive $1.5 billion from the time they've started implementing Six Sigma. Motorola is about 16 billion from 1980s so far. Johnson & Johnson 500 million, Honeywell 600 million. So we are looking at a huge saving through Six Sigma, and it also has a direct impact on the revenue. Right. So here is an example on how a variation is calculated. I hope you understand this particular plot. So you have something called a lower specifications limit and upper specification limit. So these are the, if you plot a particular data on a graph, right? And this is how the shape of the data will show up. And somewhere this point would be the central tendency, which is the average of the transaction, right? So from this point to whatever point the data is available, that would be calculated as the variation. So the lesser the variation or lesser the data points close to the central tendency, it is better for the process, right? So the key objective of Six Sigma would be to reduce variation and bring as many points as close to the central tendency, right? Any question here, Ronald?
No, that's fine. I see. So yeah, I see the parameters, the lower and upper specification, data points, and the objective is to be in the central portion of the right in the center of the within the parameters.
Right. So whenever lesser variation, there'll be fewer defects, and it drives efficiency and gives a better performance. Right. And Six Sigma methodology, especially on a green belt level. So we have 5 different phases. The first is define, right? And then measure, analyze, improve, and control. from the design standpoint, for example, if we are looking at implementing a new service or implementing a new product, we use something called DMAIC, which is define, measure, analyze, design, and verify. This is mainly used to introduce something new, right? Currently, for this training, we will stick to DMAIC, which is define, measure, analyze, improve, and control. Have you heard of this term DMAIC?
No, not DMAIC.
Okay. Okay. So that's probably mostly used in introducing a new software or introducing a new product. They're using Six Sigma to, in the implementation stage itself, you have the least number of defects so that they don't have to rework on driving the efficiency.
Okay.
Now, at a very high level, and define what we're trying to do is we identify what are the customer expectations of the process, right? And then in the measure stage, we will measure what is the frequency of defects, and the analyze phase, why, when, where do these defects occur, and improve, how can we fix the process, and control, what we do is how can we make the process stay fixed, right? This is at a very, very high level. We will look into details each of these stages. So another way of putting in what I just mentioned, first in the define phase, what we do is we first look at the problem as a practical problem, and we convert that into a statistical problem. And then we come up with a statistical solution to it. And that statistical solution, we will convert into a practical solution. Right. So in the define stage, mostly we look at who the customer is, what are their issues, and what are their problems, and then we will try and define those problems, and then we will start collecting data to measure the level at which these problems the customer has, and then we will arrive at a statistical solution through various tests and analysis, and then we will convert the results that we get into a practical solution by putting the right method to improve. Got it? Do you have any questions here?
Sure, go ahead.
And these are some of the tools that we'll be using. So in the quality management operations, DOE, benchmarking, SIPOP, problem solving techniques, re-engineering. And this is something we've already discussed at a high level, and we will go through this in analyze phase. Now, here are some more terminologies that you'll have to keep in mind. I hope you understand defects. Now, there's something called defect per million opportunities, which is nothing but DPMO, right? So we will look at, for each unit of a service or each unit of a product, we will look at there are how many defects, and for a million opportunity, how many defects are there, and that's how we measure Six Sigma, or we look at how efficient is your process. Right? So these are some of the terminologies that you need to keep in mind. DPMO is nothing but how many defects are there in a process for a million number of transactions. That is nothing but a DPMO. And rolled throughput yield is the total yield of a process. First time yield is the first time when you process a transaction, what is your output? And then there's a sigma value. Sigma value determines your variation in the process. Did you hope you're clear on that?
Sure. So the FTY, it's basically, it's like a first time yield. It's how many defects are within the first within the launching of a first time process, or correct?
It's the first pass yield. For example, let's say you have to place an order, right? In the supply chain terminology, if I look at it, you have to place an order, purchase order, right? You place the purchase order. So let's say you had to create 10 purchase orders at a time, and you created 10 purchase orders. During your first attempt, only 8 orders went through and 2 of the orders did not go through, right? So your first pass yield is 8, right? So 8 out of 10, which is 80% is your first pass yield, right? And then again, you do the rework, then you push another PO through. Then your total output becomes 9 out of 10. That clear?
Okay.
Okay, so right. And you understand DPMO, right? DPMO, defects per million opportunities.
Yeah, and what's the calculation for that?
Yeah, I mean, just a terminology. For example, if
Oh yeah,
if you're performing 1 million transactions, or if you're creating 1 million purchase orders, how many defects do you have total? That's called DPMO.
I'm familiar with DPMO and PPM as well.
Yeah, and this is a very, very important terminology because based on this, we do the Six Sigma calculation.
Okay, and are we going to go into that
Detail
in a few slides in details?
Right. So we will look into all this in the later phases of Six Sigma.
Okay.
So here is an example. If your process is at a Six Sigma performance, right, the first one, which is called as a world-class benchmark, right? Your DPMO, you will only be 3.4. So for 1 million transactions, your defect is only 3.4. And you'll be performing at a 99.9997% yield, right? And the cost of operations per quality would be less than 10%, right? So if your process going at a 5 sigma, the total DPMO or defects per million opportunity would be 233. So you have an opportunity of improving 10 to 15% of your process. And 4 sigma is usually the industry average, 3.5 to 4 sigma, where your defect rates would be 6 to 10. Per million opportunity, you'll have 6,210 defects, where you have an opportunity to drive efficiency on 15 to 20% of your process. And thus 3 would be 66,000. And for a 2 sigma, it will be 308,000. And for 1 sigma, it is much beyond repair. Do you understand this table?
Sure.
Okay. Now, like I suggested before, how the project is done using a Six Sigma. First, you have a practical problem identified, and then you initiate a Six Sigma project. Then we arrive at a statistical problem. Then you find a statistical solution. Then you put a control plan, and then you have a practical solution that is implemented. And then you put a control plan on top of it, and you drive the results. So the key characteristics by doing a Six Sigma project, it has a huge impact on profitability or a significant strategic value. So you improve certain metrics, or you drive efficiency and improve profitability, right? And some of these problems which you cannot easily solve through a traditional method of improving, we implement Six Sigma. And from a goal standpoint, what are the areas that Six Sigma can help? For a 1 to 2 Sigma performance process, we simplify and standardize the existing process to start with. And once it reaches a 3 Sigma level, we use the basic tools of problem solving, right? And for a 3 to 5 Sigma performing process, we drive characterization, we try and optimize the process, right? And something once it reaches a 5 sigma, then we use design for 6 sigma for the future processes to initiate without any defects. Now, some of the results using a 6 sigma can be, it has a huge impact in improving the overall customer satisfaction. If I can relate this to the supply chain world, on-time delivery. Right? On-time delivery is one key metric where customers really look at receiving their products on time, and that's a huge metric that you can improve using 6 Sigma methodology, right? And reduce cycle time. For example, if you're delivering a product to a customer in 30 days and customer is still unhappy because it takes 30 days to receive the product, driving efficiencies in the process, we can reduce from 30 days to a 15 days cycle time using 6 Sigma, which drives overall customer satisfaction, right? And it can increase productivity. Basically, it eliminates waste at different levels, and it can improve productivity and add more value to the customer. And improved capacity and output, and reduce total defects, and increase product and service reliability. We can actually rely on a product that coming through a 6 Sigma design, right? And decreased work in progress. The rework that you are required to reduce the defects is something which can be efficiently driven through 6 Sigma methodology. And the process flows will be improved once we do a 6 Sigma project. Any questions so far?
No, I'm okay.
Okay. Some of these slides I'll be skipping. So I hope if you have any questions, you can quickly stop me and ask. So now on this slide, just wanted to highlight one point, right? Now we have 2 lines here. So one is lower specification limit, which is, let's say, set by your customer, and your upper specification limit is set by customer. For example, your target is here. So let's say your customer says, right, my target of receiving a particular product is 15 days, right? And I am okay if I receive within 5 days. I'm okay if I receive within 25 days. So your upper specification limit is 25. Your lower specification limit is 5 days. And then you have a target of 15 days, right? And then we calculate using our current traditional method, anything which falls between 5 days to 25 days, we consider it as good, right? And anything which falls outside is considered as a bad process, right? However, if a customer who receives 7 out of 10 products within 5 days and 3 of the products in 25 days, right? And every time he places the order, he will be expecting a turnaround time of 5 days. But sometimes it comes in 25 days, right? And I'm sure even though he gave you an upper specification limit of 25 days, he'll be unhappy because there's a huge variation from what we deliver, right?
Yes.
But from the conventional method, it was okay for us. I mean, customers already given you an upper specification limit. We are okay to receive the product within 25 days. But the person who's receiving, he's unhappy because he's not able to predict when can he get his product, because there's a huge variation. So that's where the 6 Sigma comes into picture. We look at reducing the variation, right? We'll probably stick as close as possible to the target by reducing variation, and so that customer can predict when it is going to come, and which will improve overall customer satisfaction. Right. So how we do the problem solving, right? So it's not just about looking at a target and seeing if the products are received on time. We look at various independent variables that contributes to the output, right? So it's y is equal to f of x in the multiple x's, right? An on-time delivery is affected due to multiple things. There could be a delay from our suppliers. There could be a delay from creating the orders. There could be a delay from planning activities. There could be delay from sourcing activities, you know, or there could be multiple things. So we, in a Six Sigma methodology, we look at all these factors to ensure the yield is, you know, how it is calculated, or how the Y is driven, from where do you have a problem, and then we'll try and fix each one of those X and minimize the variation as much as we can. And this is one of the examples for a conventional strategy.
I'm sorry, can you repeat that? Can you bring the slide back?
Yeah, this one?
Yes. What was that?
Yeah, so this is on the conventional strategy. Which process variables have critical impact on the output effect? So if, for example, F is driven, or the crusher yield, let's say the yield is driven through multiple X's that's mentioned here. So instead of, let's say, I'll come back to this from here. Right.
Yes.
So let's say here we are looking at if one of the X's, for example, is at the optimum level, like to produce a certain product, right? The material type we sourced is right. The speed at which we are processing is right. The lubricant that we are using is right. So as the yield, right? So we are only looking at yield. However, we try and relate, for example, speed at which a particular amount of lubricant is applied to a certain speed, right? And that's the correlation between a particular tool or lubricant that is used with a certain amount of speed, and it is fed to the right machine to give you a particular yield. Which means that we look at the right amount of the best possible solution, or the best possible you know, amount of each of these X's used, the right proportion, which is directly impacted on the yield, right? That's what we do in a Six Sigma methodology. We try and relate each of these X's at different combinations. We try to come up with a solution, right? Instead of looking at what is set already, that is your conventional method. We look at different combination to drive the right amount of efficiency. Is that confusing?
No, it's okay.
Right. So the first is when you develop a process, you have a certain number of X's, right? And a possible amount is already determined, right? That's a conventional method, and we are used to a particular yield. In a Six Sigma process, what we do is we do something called design of experiments. We look at the right amount or right amount of combination between these X's so that our output is improved. Basically driving efficiency by changing the X's that is required. The combinations change. I will explain you during the
Sure, no problem.
Design of experiments when we come there, right?
Okay.
Okay, and this is one example on how a bad process and good process performs. So once we do a Six Sigma project from your old standard to new standard, how does it change? For example, if you look at here, right here, this is your lower specification limit and this is your upper specification limit, and you see multiple data points which is going beyond specification limit, and this is much far away from the central point, right? And then we drive a Six Sigma project and we drive efficiency and we bring the variation as less as possible. And obviously you will have a shift from your old standard to a new standard. Just an example on how processes improve. Now, so to initiate any kind of projects in your business, there are a few things that we look at. First is the voice of the customer. So anything that a customer complains to you about, right? That's a problem, right? You will have to always give first preference to the customer. Customer always comes first. And anywhere or any process or any product that customer raises a voice, and that eventually turns into a problem, a practical problem, and then we go ahead and analyze. And second is a problem that can come through a business, right? That is nothing but, let's say if there is the profit is coming down drastically year on year for a company, that straight away is an issue that you have to work on. And third is a process driven problem. For example, the metrics that we set for each process, if that is not performing very well, it immediately triggers for a project. And so that, for example, if your on-time delivery is only 60% out of 100, then it automatically, to have a project that where you have to improve from 60 to an 80 or a 90. So these are three main areas how we identify projects. Any questions here? Hope you understood this.
Yeah, it's are these slides going to be made available after the training?
Yeah, we can share it after the session.
Okay, okay. I'm taking a lot of notes and yeah, it's a lot.
Yeah, I know that. Which is why I said this can be shared to your company. Yeah.
So basically, it's customer driven or profit driven or process driven.
Absolutely, yeah. And that's when you come up with a project, right?
Mm-hmm.
How do you start? How do you start a project? You need to have an input to start. So either customer tells you there's a problem, or it's already clear that there's an issue with the profit or a key business metric, big business metric, or there is a process metric that is failing. So it immediately triggers for a project. Now, in the Six Sigma world, right, there are 4 different categories mainly. So first one, obviously, an yellow belt. So yellow belt projects are usually initiated by at a process or an agent level, where if he has to fix his own process that he's working on, his own area of work, and we consider those are yellow belt projects. Green belt projects is a little bit more complex, where you will probably look at improving your peers. For example, if you have a team of 5 people or 10 people who perform the entire purchase order processing or do the planning activity, you can initiate a green belt project. A black belt project would be a bigger team. For example, a team of 150 to 200 people, right? Who's taking care of entire sourcing organization, for example. So you drive black belt projects. And master black belt is a person who will mentor a black belt project, who does a project at a service delivery organization level.
Okay,
right?
can you repeat what is it for green belt?
Yeah, so green belt is a specific. Okay, let me in the next slide have a little more.
Okay, sure. Yeah, no, master black belts. Yeah, I know that they're usually they guide black belts. Black belts need the support from a master black belt, but master black belt will be more of a executive or top level senior directors or whatnot.
Right, right. So, so how it works is there's a champion, right, who will sponsor a project, and then you have a master black belt who who drives project or who looks after projects across a service delivery organization. For example, if your team is a supply chain organization, if you look at that entire organization, you'll have a master black belt, and then for each vertical in the supply chain, let's say a planning, a sourcing, uh, customer order, customer experience, so you'll have some of these departments. Each department will have a black belt who will look after the projects. And then you have your team leads who is looking at a specific function within a planning. For example, a forecasting is something a small team takes care of it. So that's where you will drive green belt projects. And then a person who's just doing one particular activity, and if he has to initiate a project within that, will be considered as a yellow belt project.
Okay.
Okay, so a green belt is more specifically about 15-20 people team, right?
Mm-hmm.
Who's working on a same metric which requires an improvement. Then a green belt project can be initiated, and there'll be one project lead, and who will be the green belt project lead who gets the certification, and you will be assisted by a black belt who will mentor you on what tools can be used. And then we have a master black belt who will approve your project from technical standpoint. And you'll have a process owner or a champion who is the owner of the business, who is a vertical leader, right? And he's the one who will sponsor the project. And that's how it works.
Okay.
Now, in order for you to complete a green belt certification, first thing, you'll have to obviously go through a training, formal training. And then you'll have a test that you'll have to go through. And you'll have to initiate a project and close the project. This is the basic criteria of completing a green belt project.
So, okay, so okay, so it's not just so I thought it was so it's requirements is the training, of course, upon completion of the training, get certification. Yeah, you completed the training. There's also a requirement you have to take the exam. Now you're telling me there's also another requirement that you have to do.
Yeah, so
Yes,
it
you
varies
have to
from
complete.
organization to organization. I don't know how your organization works. So ideally, right, in a
Oh, okay,
world,
okay,
Six
okay.
Sigma world, ideally in a Six
Understand.
Sigma world, you'll have to complete a training. You'll have to take the test. Some organizations give you a green belt certification immediately, but the true value comes only when you take up a project, you implement DMAIC, starting from define to improve,
Sure.
control, and then you close it,
Understood.
get an approval from your master black belt, get an approval from the sponsor champion, then it will be considered as a complete certification. That's when you learn, right?
Understood.
So here's one example. So green belt complete projects by devoting less than 50% of your business time. So doing project is definitely not your full-time job. You are initiating a project within what you're working on. That's when it is considered as a green belt project. Black belt is a person who is dedicated to 201 to 250 people to drive projects, right? There's a different roles in a quality, and master black belt is the one who give guidance to the black belt to drive a bigger business metric, and who will eventually communicate with the higher authorities in the company, C-level executives. A champion who will basically scope out projects and he'll give the sponsors any cost related to that. He owns so he owns a bigger organization like 1 to 1,000 people. And here is some challenges and misconception about Six Sigma. People think, it's just for manufacturing, which is not the case. Proper implementation needs a statistical genius, which is again a wrong conception, because a normal person who is not very savvy about statistical tools can also get a certification at a green belt level, who will be assisted by a black belt who will be a little more expert in a Six Sigma quality tools, right? And then Six Sigma needs heavy investment on resources and system, which is also not true. Six Sigma is the most cost-effective way of implementing a project. There's no real spending. We find solutions within a process. But Six Sigma can identify projects which can have a bigger impact if there is an investment. For example, by end of the project, you improve your metrics by driving efficiencies in your process, putting in the right processing in place. But you can also come up with an idea of automating something, right, which would require an investment. But that will not be part of the scope of Six Sigma project as such, but that will be an idea which is generated out of doing a project. And it can be used only to handle big projects. That is also not true. It can be done part-time, which is true, because at a green belt level, we can do it. It needs only a clear understanding of statistical packages. It can be used to solve day-to-day problems in process. Day-to-day problems cannot be solved using Six Sigma methodology because it requires analysis. Day-to-day problems can be solved only driving operational excellence, or a quick fix lean methodologies can be used for day-to-day problems in process. But in order for you to drive a problem which does not have a solution in front of you is when you use a Six Sigma project. All right, any questions so far, Ronald?
No, I'm fine.
And another few challenges that you would come across when you take up a project: stakeholder support, right? Any project, for example, you take up, especially a Six Sigma project, requires a lot of help from different places. The first part would be stakeholder support. So when you have a project in mind, the first thing that you do is go to your stakeholder who owns that business and take his approval. So we need to make sure that is going to be one of his priority. Otherwise, you will not get the necessary approvals once you move forward. So it's very important you have a stakeholder support. And then you have your measurement systems in place, especially if you're collecting a particular data to validate a problem that you have. If you don't have the right measurement system in place, you obviously cannot implement the project. Let's say you have an issue in your inventory, but you don't have any system to measure what is the main problems in those inventory, then you don't have any data points, and what the data that you collect is incorrect, then a project cannot be successful. So you should always fix your measurement system when you start a project. Then analyzing a piece of data is good, but spending hours and hours using variety of tools to extract some information, which will cause analysis paralysis. What do you mean by that is, you might have huge amount of data, and if you are to go and start analyzing point by point in that particular data, which will consume a lot of time, and you will eventually not complete a project. So in Six Sigma, what we do is we select samples, right? We do not probably analyze the entire project. If you have enough support or tools for that, which is good, but otherwise we will take samples and then we analyze samples and we look at different combinations and analyze the data, and that's how we complete a project. And communication is key at every stage. Whatever.
I actually do the number 3 point right now, the analysis paralysis. Yeah, I use about 3 different sources to extract data, and I still have to analyze the data, manipulate the data manually to try to get as close as I can to 100% accuracy. and it consumes a lot of hours, for
Absolutely, yeah. That's a big challenge. I mean, it depends on what data you analyze. I mean, it could be a requirement for you to ensure you analyze the complete set of data, but to derive at results, you probably don't need to get into the complete data. You can segregate data into different classes, right?
Yeah, but like in supply chain management, like now, let's say for example, like material coverages. So we'll extract large pieces of data for bombs being used in manufacturing. So it'll be thousands of parts or part numbers, and I'll do my extraction from SAP, do an extraction from another tool that we use in with simultaneously with SAP, and then another internal tool that we created, and I extract all the data from all three sources, and it's still not accurate, so I have to analyze it myself. This is large data files, you know. But yeah, it takes a long time.
Right. I understand what you're saying, because even the world is evolving, right? Eventually, we ended up implementing too many tools, right? And the data points is spread everywhere, and it takes so much time for us to collect from one place to another and then put it together. I know what you're talking about. It's a huge challenge, yeah. So moving on, communication is key at all levels. So even if you are a project lead, right, you have 10 employees reporting into you, who's helping you out driving a project. It is very important we keep everybody in the loop. We communicate from top to bottom so that you get the right amount of support, because you'll find a lot of resistance from everywhere, right? As an employee who's reporting into you, he might be, his priority would be completing his work than getting some data for you, right? But eventually, if you communicate the objective of driving a certain result on a periodic basis, he will understand, he or she will understand what you're looking at, and this communication is key to avoid resistance, and you meet your timelines of project execution. Okay, so some of these things we've already spoke about. You can read through and you have your material in place. Okay. So now we're getting onto the DMAIC methodology. So today we will try and cover up the complete define. And then tomorrow we will do the measure. And next week, the first day, we will complete and analyze. And that's where we will have to go through analyze a bit of data, learn a tool called Minitab, and drive different tests that is required for you to do. And from Greenbelt standpoint, you just need basic understanding of these tools. If you have a dedicated black belt who's an expert who can actually help you with those tools, then you have improve and control can be covered on the last day, and that's how we will go about it.
Okay.
Okay. So do you want to break or something now, and then we get back to the define?
Okay. So what time are we gonna finish today?
Do you want to take a quick break and then?
Yeah, sure. But my question is, to what time will we finish today?
We'll see. We'll try and finish early.
But what's the schedule? It's the schedule.
What time is it for you now? What time is it for you?
For me, it's 10:55 a.m.
10:50.
I'm in Eastern Standard Time.
You're in Eastern Standard Time. Okay.
Yeah, I'm in New York.
Okay. So this training is scheduled till about 3:30 or 4.
3:34, or let's say 4 Central Standard Time, or what?
Yeah, let me just check which time zone it is. So we started. 38, 1 hour now, right?
It's central, right?
Yeah.
Okay.
So basically,
Okay.
7 to 8 hours of training is what is scheduled. But we'll try and finish as early as we can today.
Sure. Okay. So give me 5 minutes and I'll come right back.
Yeah, just a 5 minutes break and we get back.
Okay.
Okay. Thanks, Donald.
Hello.
Hi, Ronald.
Yes. Hi. I'm back. Sorry.
Oh, no problem. Let's start.
Yep.
Okay, so we're starting with the define phase now. The key objective of define phase is defining the project, right? And we will see how we define the project. And key deliverables would be completing a project charter and a high-level process map. Completing a project charter basically, identifying who your team is and what should be the timeline, etc. And then you will also look at a high-level process map where you're doing the project. And to elaborate a little more on the alignment standpoint, we'll have to ensure project leader and project sponsor are both aligned with the right business strategic imperatives, scope, improvement, goals, timeline, estimated benefits, etc. And then you'll have a team launch. You will identify who are the people who are going to help you in driving this project and launch the project. And then you create a SIPOC process map, which I will show you. And then we will set up a toll gate review. So every phase, once you complete, it goes through a toll gate review where you will have to take an approval from the sponsor, black belt, and the project leader. Okay. Now, how do you identify your customers? So you can have two sets of customers. One is your external customers. External customers can be the person who is receiving your service, right? He could be the end customer. He could be your supplier. He could be your distributor, a retailer, anybody in a supply chain organization, anyone whom you are interacting with, right? Or who receives the output of the transaction that you're performing can be an external customer. Your internal customers would be your immediate manager, or if there's any finance implication through driving this project, he could be your internal stakeholder, or any senior level executive who's really interested in a particular project. That can be your internal customer. I hope it's clear.
Yes.
Now, we've already spoke about different voice of customer, right? And then customer provides you a customer specification limit, a lower specification limit at which his tolerance level, right? You have a lower and upper specification limit. That would be the tolerance level and at which he will be okay to receive your service, right? And he'll also give you a target value. A target value can be, let's say, I want my orders to be received within 90% of, should be 90% of the orders should be received within 15 days, right? Something we already discussed, right? Now, now if customer might suggest you certain value, right? And that may not be the target value when you do a project. That's something we'll see, because we will be taking a realistic value on how a project can be completed. Customer expectations might be at some level. However, when we baseline the data, we will see what his expectation is out of reach, or which is not practical by doing a 3-month project. Then in order for your project to be successful, we'll arrive at a number which is achievable, right? Which will be verified by your customer. We will discuss a few of those things in detail later, right? And that's how you identify your VOC. So VOC can be identified through a customer complaint or by rolling out a survey to your customer, right? And these are the different ways in which we can collect the VOC. Surveys can be one: past complaint, service issues, quality issues, delivery issues. Customer scorecard, which displays all the metrics that you're working on, can be one way of identifying a VOC. Then there are other ways in which we can collect the VOC. We can do a market research. This is more particular to a consulting kind of business. If you are in, you do not get a direct VOC because you don't have a customer. Then you depend on market research and those metrics, data studies, the audits conducted. If you are a financial firm, you conduct your audits, past decision behavior tendencies, technology research, focus group interviews. So depending on different needs of doing a particular projects, you look at different ways of collecting your voice from the. These are some examples on complaints, log cost, fast, excellent for CTQ definition. Can different sources of existing customer data where you get it from. Now, first thing, when we say there's a problem, right? So problem can be big, right? People can convey a message in a very high level, saying that I really don't like your service is a very generic term, right? And customer might say your delivery is absolutely not doing the right job, right? That could be a very generic statement. And it is very important for us to identify a project CTQ. What is critical to quality, right? Now, first thing is, who is your customer, right? And what does she or he think is critical to quality, right? And that becomes very specific, right? And who can help define the issues. So customer mentions a specific issue which is very critical to reach the right output. Then we'll have to look at who can define that issues for us. And if it may not be customer who will tell us directly, we'll have to reach out to somebody else on behalf of customer who can provide us that kind of information. And who are the people who are involved which will affect in getting those particular data from the customer. So that is very important, identifying the right critical to quality, right? Now, this is a very important table that you see here. So purchasing, so if you look at quality, price, and delivery, right? These are the 3 factors which is considered when you do a purchase, right? Quality, we look at 0 defect. Price, we set a specific limit, saying that I cannot spend beyond this particular amount. And then delivery has to be a certain percentage, right? So now there are 3 things to purchase. Now, when I pick up a project, right, I cannot say I'm going to improve the purchasing process, right? That's a big term. In purchase, you have 3 sub factors: quality, price, and delivery. Now, which one am I going to focus? Am I going to focus on getting my deliveries on time, or am I going to ensure I reduce the cost of purchase on a particular item or overall purchasing cost? Or am I going to work on the number of defect items I'm receiving from the supplier, right? So you zero down to a particular metric, and that will eventually become the objective of your project. You get that? Any question on that?
I'm okay.
Okay. Now, this is another model of determining the critical to quality from the customer. So, for example, if you don't know your customer very well, and you have to really collect some attributes which is going to impact the customer and start a project, and you divide this into 4 different buckets. And the first one, obviously, you look at must be. What are the must be factors in which customer will be completely dissatisfied if you don't meet those requirements? That comes under the must be bracket. So these are the metrics in which you have to meet, right? If you are not performing to the must be level, you really have to fix this. And the next level would be some of the customer expectations little beyond what your basic metric is, right? Every customer will have an expectation, right? I want my orders to be in 90%. I'll be very happy if some of these commodities, I get it at 93%, even though my metric is 90%, right? And that comes on the linear factor. And beyond that, if I'm able to take the entire delivery to 99%, that will delight the customer, right? And these are the 3 different buckets in which we can quantify or put a right quantity or quality way of identifying customer needs and what will make them happy or meet their expectations at a higher level and what will delight the customer. Right. Now, there are 2 other ways in which how do you select a project, right? You might have multiple ways of selecting a project. First is the obvious one, which is your repetitive basis problem. There is a noise always from a particular area. You always know there's an issue. We need to come up with a project. There's another way of picking up a project is brainstorming approach, right? You get the right people into one room and discuss, do the brainstorming, and we identify multiple issues. You try to bucket them into different categories, and whichever has the highest impact one, you would select for driving a project. Now, once you have a project, right? There are 3 things is mandatory in a define, right? Which goes on to the project template that you will be doing. The first is business case, right? And business case is nothing but a very high level articulation of the area of concern, right? And it basically answers 2 questions, right? One is, what is the business motivation for considering the project? And 2, in what area are you planning on improving the effort? At a very high level, you define a business case, right? And second is a project charter. So it's a little more detailed than the business case. Business is at a very high level. You further document the improvement effort, right? One is basic project information and simple project performance metric, right? I will tell you in the next slide how that is defined. And then third, you look at benefit analysis. And what would be the benefit that you are estimating if I complete a project? So first you define the business at a very high level and what is the need for doing that project and which area would I be focusing. Second, you're defining further with a metric. Where am I performing currently? And third would be an estimation of analysis on this much of dollars I would be saving if I complete this project. These are 3 core components of a project selection, right? Now, there has to be governance for every project that you identify, right? And to get you a business case, right? Mostly a champion is the one who gives a business case for doing a project. And some of the resources we can collect the data for you would be business unit members. A project charter, Six Sigma black belt will help you with it. And resources are mainly by champion and master black belt, because they are the one who will give the go ahead to align the right resources for your project. And then on the benefits calculation, you will have to depend on the financial side of the business to validate whether you have got the right calculations of the estimation of a project. Right? That your Six Sigma black belt can help you, or a champion can help you from governance standpoint. And then do a very structured approach. So some key metrics, I mean, you obviously put, you break down your KPIs into different levels. This one I will come back to you and explain. Okay. Any questions so far?
No, I'm okay. Thanks.
Okay. Now, business case is something we already explained. Now, to give you a little more detail on how will you create a business case, right? First question would be, does this project align with our business initiative? What is the focus of the project team? Right? And what impacts will project have on other business units and employees? And this is very, very important. You might be driving one metric from our end. Right? We might be improving or showing a better number from our side, but this can have a different negative impact to another work stream, right? And that's very, very dangerous because obviously you improve your metric, but you pushed your problem to somebody else. So you should always analyze that. If that's really impacting somebody else, then you have to involve them also in your project. And then what benefits is derived, and has the values of benefits been qualified? That is something which can be done with the financial team, or you can look at different data, which is an approved data with financial numbers to ensure that value is right or not. Now, just to give you an example on how it should be done. So during fiscal year 2005, the first time call resolution efficiency for new customer hardware setup was 89%. So this represents a gap of 8% from the industry standard of 93%. That amounts to 2 million of annualized cost impact. Now, there are few things that is addressed here. First of all, we are clearly articulating from what frame time and what was the efficiency percentage. That's clearly mentioned. And what is the need of doing this project? Because there's a gap from the industry standard. We'll have to, this project is so important that because this is much away from the industry standard. And what is the estimated impact if you bridge that gap, you will get a saving of 2 million, right? And this is how clearly we define a business case. Is that clear?
Yes.
Yeah. So I'll show you one example. It's not there. Okay. I want to show an example of a bad business case and a good one. Okay. A bad one would be in this case by saying the first time call resolution efficiency is poor. There is a need to improve. Or just by saying the first time call resolution efficiency is 89% and we need to improve. You know, those are bad examples of writing a business case. We need to have a time frame. You need to have a number. You should have a need, why, and explain why that number is not right. I mean, not a good metric, and how much value we can derive out of improving that particular metric. And we need to cover all these aspects to get a good business case example. Now, can you give me an example from your experience and define a problem?
Okay, fill in the blanks.
Just pick up any of your metric and just if you can define.
I'm sorry?
You can just pick up any of the metric from your business, and if you could just write a simple business case, take 1 minute time, and you can read it out to me. Did you get the question?
Okay, so you just want me to verbally fill in the blanks here?
Yeah, if you could, from your business example, take one example and keep this as the example, right? Mm-hmm. And just tell me any of your metric.
Sure. So I mean, I can say, for example, if you go back to the slide with the fill in the blank example, I could say during the 2018 fiscal year for our organization in North America in manufacturing, our manufacturing business unit, we had on-time delivery from our suppliers of 93% and the versus the target of 90%, and this represented a positive value added to our operations.
Okay, so you're saying a positive one, 93% from 90.
Yeah, 93% on-time deliveries from our suppliers, and our target baseline was 90%.
So how is that a problem?
No, it's not a problem. You want me to identify a problem?
Yeah, absolutely. So we are building a business case, right?
Okay.
There's a need for a project. There's a need for doing a project, right?
And okay, so we had issues in so during the 2018 fiscal year, we had a NCRs. We had quality defects of I think our target was 94% of parts to be received in without any NCRs, without any quality defects, but yet we received 87% of parts that met our requirements. So it gave us a variance of it was 87%. Yeah, it gives a variance of 7%. We didn't meet our target, our baseline.
Right. So now you're creating a complete story of what happened, right? Now, how do we convert that into a very crisp business case? So you look at your fiscal year or whatever time frame that you've taken. Our target was X percentage, and we met only X percentage. Right, simple. And why is it important for us to meet that percentage? So you need to create a small case on that. What happens if you don't meet it? Or what happens?
Yeah, so we have a dollar value that I can't remember what it was with that 7. So basically our target was 94%, and we fell short of it. Our actual line was at 87%, so we fell 7% short of our target, which represented I forgot the dollar amount. Let's say, I don't know, $4.5 million in additional operational expenses, which also led to us impacting our on-time delivery to our customer.
Excellent. So that's the connection. So that is totally impacting your on-time delivery. That's the end result, right? You can have X amount of orders, right? X dollar amount of dollars going to your end customer late. which can impact a cash flow of that X amount of dollars, which would be of financial implication to this project.
Yes.
Yeah, that's how we calculate and put it in a very simple term with a time frame.
Okay.
What is the metric? What is the gap? What happens if we don't bridge that gap? And what would be the total value of impact?
Okay.
Simplify a business case. Okay, so that's clear. And so when you define a project charter, so we already found out why is the project worth doing, what is the consequence of not doing the project. And in the problem statement, we have to provide a description of pain, what does not meet the customer need, and then you set up a goal statement. Now, goal statement would be very opposite of problem statement. We will say, by a particular timeline, we would like to improve the metric from 89% to 90%, which will give us an overall estimate business impact of X million, right? It will be the opposite statement of problem statement. Only when your problem statement is crisp and clear, we can derive at a goal statement. And a goal should be a smart, right? Should be specific, measurable, and should be realistic, right? And you should be able to implement or able to attain that particular goal, right? And scope. Scope is also very important. We need to clearly define which area are we going to target. If I say on-time delivery, are we looking at on-time delivery of the entire business, or am I looking at improving the on-time delivery of a specific commodity that you manage, or are you going to improve the on-time delivery of a set of commodities that you are going to manage, or a specific profit and P&L account that you're going to manage? So you should be very clearly scope out your area of project. And then you also set up milestones. So you create a project plan with dates. On what date am I planning to complete my define, improve, or measure, analyze, improve, and control. Then you come up with your project team. And this is how the template would look, right? This would be your first page for a project charter. You put your project name, your date, then you define your business case. Those three factors we discussed should come here. Then you put a goal statement. Then you put the expected savings if you do this project, and a problem statement, defect definition. This is also important. What do you consider as a defect? So let's say if I am calling on-time delivery is a problem in the problem statement, and how do you define an on-time delivery, right? You have to be specific. For example, any order. So if you have two dates, right? One is receive date and target date. So what do you call in your business? Is it expected date?
Mm-hmm. Yeah, we have parameters for deliveries, on-time deliveries from our, let's say, for example, from our suppliers. So we have a plus or minus 3 days. So
Okay.
yeah, so if it's anything that gets received in before the 3 days or the lower specification limits, then the supplier will get negatively impacted, as well as if they deliver outside, let's say, plus 3 days. So if I give my expected day or agreed upon date is let's say December 15th, if they deliver December 12th, then they're okay. So they're still okay. They're considered on time. If they deliver December 11th, then they're negatively impacted. So that's our policy, plus or minus 3 working days. business days.
Okay, so there are two metrics that I could, two dates that I could think of. One is expected date, which is a date that you're giving to your supplier, and supplier comes back and tells you, this is the agreed date, which I will supply, and you say okay to it, right? And then you have a delivery date, right? So you might be calculating the on-time delivery, which is expected date minus delivery date, or agreed date minus delivery date. All right, these are two different.
Yeah, no, right. No, we do. It's the agreed upon date. So
Agreed upon date.
yeah. So once we place a PO to the supplier, they give us a defined date. Yes, we give them what we need, but upon placement order, the supplier is also sending us an order acknowledgement to confirm that they're going to be able to deliver, let's say December 15th. So that December 15th will be the locked in delivery date, and then our policy takes into effect our plus or minus 3 days.
Okay, so what you do in your defect definition is you clearly articulate a defect is considered as anything in a delivery date with minus the agreed date plus or minus is a defect, right?
Yes.
Yeah, so anything which falls outside that would be considered as a defect. So that formula is something you'll have to clearly put it here. Then project process start point. So where does your project start? Process starts in the project area that you're doing. Process endpoint. In scope, out scope, something we already discussed. And then in the below, we put all the tasks for a project plan. Let's say define, measure, analyze, improve, and control. You put a start date, you put an end date, and you also track an actual end date. Whenever you get a sign off on each toll gate, you put the actual end date, and then your team members, what role are they going to perform? Let's say you put your name as project lead, and somebody else's name, who your boss or your master black belt, a project team member who's going to help, they'll be considered as a project member, right? And if there's a metric which is defined, you will put it here. So this is how a project charter sample will look. Any questions from any of these?
No, I'm okay.
Okay. These again, a few points that you'll have to read and understand. So basically, your project charter is dynamic, which means it continues to evolve through the project, which is there can be changes. Your team members can change. The metric, to some extent, it can change, but should always try and keep your project metric constant once we move on from define phase. These are some of the things that you'll have to keep in mind when you define a project charter. I'm just leaving a few seconds for you to read. These are a few points we've already discussed. Now, this is the RACI model, we call it, or RACI model, we call it, right? This is how you identify your resources, right? And their accountability, consultation, and inform. So let's say you put your champion's name here as one of the key stakeholders. Should he, if he has to approve only the define phase, measure he doesn't need to approve, right? And he'll be a informed party on the analyze phase. But once you complete your improve, he has to give you an approval, right? And in the control, he just needs to be informed. So when you initiate a project, you will put all the names who are the key stakeholders who should give you either approval or who should be kept informed because they are important to this particular business aspect. And then you clearly articulate. So once you put this chart in here, and once you share this with your stakeholders and black belt and master black belt, you clearly know which are the toll gates whom you should have a review with, right? For example, in resource 3, it could be a subject matter expert of your business. Whom you have included him in the stakeholder chart, but you will only consult your project with that particular resource.
Okay.
Right. Yeah. So this is something we've already discussed. So here is an example of a weak problem statement which I was searching earlier. So first one, it says our fatal accuracy score is 80% against the client target of 95%. We need to improve it, right? And this is how usually we just write off something, right? And how do we improve it? We say what is this quarter has been observed 80% for the last 4 months. So clearly define the time frame against the client target of 95%, which will have an impact on the customer satisfaction. And we can also say which would result in X impact. Okay. So this is the scope of project. How do we define a scope? So we have done this part. Now let me quickly go through it, even though we have gone through. So identifying the customer who receives the input and output. So for a project, there are few areas that we'll have to look at. So one is identify the customer, right, who receives the process output, the process that you are trying to drive the project, who receives the output of the project, and it could be an internal or external customer. So you know who the customer is and what their expectation is, and specify your deliverables tied to those expectations, right? It could be tangible or intangible, right? You can rank or prioritize the deliverables against each of those output, rank your confidence in meeting in each deliverable, then identify the customer CTQs, then map your process, and then you'll have to determine where the project has to be done, the critical quality. These things we've already discussed. And if you don't properly scope out your project, what happens is your team might lose interest in the project because you are touching different areas in the business where it is not really necessary or which will have a direct impact on the project. So it is very important your team stays within the scope of that project and you select the right team. you will not be able to implement the project if your scope is clearly not identified, right? You should ensure it shouldn't go to upstream or downstream, and you're distracting their nature of work. And even after implementation, you will not probably get the right benefit. And we will end up spending more time in areas where it is not ideal for improving a particular metric, and we will miss out the vital ones. Right? So it's very important that we select only a specific metric that we need to handle instead of looking at a broad project. It's in goal statement also. It has to be smart, like I mentioned before. Right? It should be measurable. The target should be attainable. A completion date is something we really have to think and put it. This is one example of a poor goal statement. Put in place a transaction monitoring evaluation system to increase the fatal accuracy. That's a very generic statement, but a better example would be increase the fatal accuracy from the existing 80% to 95% by end of first quarter. So that clearly says what we need to improve, when do we need to improve, and what should be the metric. What's the number? And this is a milestone. Okay, and financial evaluation, right? So there are different ways in which you can calculate the financial estimation of the project. So one is straight away direct metric. Let's say it gives you an improved cash flow by delivering your product to the customers, end customers. However, it can have other financial implication, as in when you have driven the efficiency in a process, you are able to save X amount of resources working, right? That can give you an additional business impact, right? You have reduced the defect, which avoided the rework of certain number of transactions. That could give you another calculation of how it can add up to your total business impact, right? So business impact is nothing but the total value, financial value out of completing a project. It could be the direct impact from the metric. It could be all the indirect benefits that you bring in, and how can you quantify that and show it to the business. Did you get that point? Or?
Yes.
Okay. So here is some example on how we come up with benefits calculation. So a sustainable impact, it can do two things for you. One is reduced cost and increased revenue, right? But we focused on the reduced cost, and it is mainly done through realization of schedule or cash flow by which period to which period. Okay, and this is the regular direct impact that we are talking about. And one of impact would be implementation, capital, and cost. This could be three other factors which also added to your overall business impact. And benefits we always annualize. Maybe we've improved a metric of a particular quarter as per our plan. So what we do is we take that total amount into 4 to make it annual. So every time we report out a benefit, we always showcase an annualized benefit. Okay, is that point clear?
Yes.
Okay, excellent. And always this calculation of your benefits should be generic, or it should be clearly defined so that people understand. and the accepted accounting principles, which means you always, whatever calculations that you do, a layman or a person who is not related to project should be able to understand. Okay, and you can clearly classify each of these benefits into income statement or balance sheet or avoid expenses. So different categories in which you can capture these benefits and add it up as an overall impact. Okay. A difference between good project and a bad project. Problem statement will be clearly defined. Defect and opportunity definition is clearly understood. Does not presuppose a solution. You obviously do not want to have a solution upfront for a Six Sigma project. You will never have a solution upfront. Then it becomes a quick fix or a lean or whatever you can call it. No need of carrying out a Six Sigma project. You will ideally not have a solution. Clearly relates to the customer and customer requirements. Aligns to the business strategy. Use the tools effectively. Data driven. These are the good project signs. For a bad project is not focused. Scope is too broad. Not clear on what you're trying to fix. Right? Solution is already known, but we are trying to build a story of a project which is not ideal for a Six Sigma project. Working on a project that will not move the needles, little or no use of tools. Okay. So let's move on to process mapping. So we clearly know now project charter, business case, problem statement, goal setting, putting the timeline, coming up with the right team. How do you calculate your business impact? So we've learned all these aspects in a project. And now let's look how we do the process mapping. So process mapping, I'm sure you're very familiar with. Anything that you do, you first list out all the steps that is required to complete the entire process. So you'll have a start and you'll have a finish, and you'll have different activities. And in some cases where you'll have a decision making and then proceed. Next level. Right. Have you done a process mapping for your business? I'm sure you have done.
Yeah, of course. We have process maps, even key process maps. We have critical path inside the process mapping. Yeah, of course, for different business units or different manufacturing sites. But yeah, we have all this.
Okay. So ideally, we do a level 1 or 2 process map for a GV projects. We do not get into the details.
Okay.
So when I say level 1, probably at this level, right?
Yes, we do this.
Yeah, this is what we do initially. And then if it is required for us to go into detail, then we do a level 2 kind of process map. For a green belt project, we don't really need to get into details. So the first step would be doing a SIPOC, right? So this is SIPOC. So the first step, what you do is you identify suppliers for a process. So let's say you have 1, 2, 3, 4, 5 steps in the overall process, right? Then for this process, who provides the input? Those will be suppliers. So identify that. And their inputs. What are the inputs? For example, to calculate on-time delivery, what are the inputs that come in? You need a agreed date. You need a delivery date. You need the receipt date, whatever, right? Those are inputs. And who gives you that? It is given by the analytics team or the reporting team, right? And what would be the output of it? Would be your on-time delivery or that metric, right? And who is impacted by that on-time delivery? Is it impacted by your end customer, or is it the impact goes to somebody else with the internal organization. Right? So this is the first level in which you do the mapping and do the sidewalk. And then this process flow, based on your requirement, you will do a level 2 process mapping like we saw earlier. Have you seen this SIPOC or have you done it before?
No, I don't do it, but the top level they do it. Like I've seen it from top level. Yeah.
I've seen it, yeah, okay. Now, if I can give you an example, let's say a metric that you have taken, right? The one which you are explaining to me during the business case example, right? Can you create a project charter? Can you create a project charter which should include the business case, problem statement, goal statement, scope of the project, and the milestone, right? And create a simple SIPOC. And will you be able to share the screen with me and show it to me?
Okay.
Yeah, so this is the template.
Okay.
This should be your one simple slide. You don't need all these columns. You can just write the headings, okay, and write the business case and put a prop goal statement and put any expected savings. It did not be accurate, and problem statement, defect definition, and where does the process start, where does the process end, in scope, out scope, and then you draw a SIPOCs. SIPOC
I'm sorry?
Yeah, the SIPOC should include your suppliers, your inputs, process, a high-level process step of 5, and then your customers. Right, this is give you the template for that. Yeah, should have all this. What time is your lunch break?
I'm okay right now. It's 12 o'clock, right? It's noon right now. But I'm okay. We can finish this exercise and then we can, if you want, we can take a break or we can continue. No problem.
Yeah, so I'm thinking if you could, if you want to take a break with your lunch break, and then we come back and discuss what you prepared. Take some time.
I mean, we can do the exercise right now. It's not a problem.
Okay, you can do this right now. Okay.
Yeah. So how do you want me to? So on this SIPOC right here. So it's just you mentioned that it's a level 2. So I've seen the I guess the level 1 process maps. Those are pretty common, right, in manufacturing and operations. So, but the SIPOC, you said it's a level 2. Are you saying that because it's more of just a bit of a higher level view?
Yeah, it's a very high level view, and should be very specific to your project. For example, if you are talking about on-time delivery, right?
Okay, so the SIPOC can be applied for different elements. So in particular case, the element that we're going to apply SIPOC to is on-time delivery, correct?
Yeah, selecting on-time delivery as your project. It should be
Right,
specific.
because you can apply SIPOC to, let's say, quality, right?
Yeah.
Okay. Okay.
Okay.
So
So
the how do you
project
form
charter, whatever project charter you make, SIPOC should clearly depend on that, right? You are mapping out start of the project. You are writing the defect definition. So you have a start point and end point. In order for us to track this particular defect in this problem, there's a start point and end point. And you, what is the first step of this and what is the last step of that process?
Okay, so the business case would be like a general statement identifying what's the situation, right? So we can say like mentioned previously, so fiscal year 2018, um, let's say we had a on-time delivery from our suppliers of 86% and our target was 94%. So there was a 8% variance, negative variance from our target, which had a $5 million negative cost impact and reduced our on-time delivery to our customer 2%.
Right.
Something like, okay, so it'll be a business case.
Yeah. Yeah. So business case, right.
Okay, so opportunity statement would be a high-level problem statement. So it'll be like, okay,
that will be specific from this frame to this frame.
okay, the defect definition, I know, so it'll be obviously the lack of on-time delivery from our suppliers to our organization, which is currently is 86%, but we clearly missed the target of 94%.
Right.
Okay, the opportunity statement should be, is it, so now I'm asking you, the opportunity statement, is that something that where we define or we can identify like what we can do to improve the situation?
No. Opportunity statement should be, we are looking at a data, for example. So fiscal year so-and-so, we had X percentage, right?
Mm-hmm.
Problem statement, which is amounting to X amount of trouble. Very simple.
Okay.
So one example, I think. Mm-hmm.
No, I'm listening.
Yeah. So remember, we check the problem statement. This is the poor one, and this is how we write a problem statement.
Fatal accuracy score. Okay.
More specific. Business case should include why are we doing this project? What if we don't do it? And which business is impacted by this, right? On all
Okay, more high level general.
general business case.
Okay, and the problem statement that I see it's more
Very
defined.
specific.
Yeah, very specific. Yeah. Okay, so it's more kind of I guess what I said. Yeah, so it'll be. So I guess what I initially said would be the problem statement. It can be
Absolutely, yeah.
Yeah, so 2018 we have on-time delivery of supplier on-time delivery of 86%, which fell short of our annual target of 94%, having a negative impact on our, let's say, on-time delivery to our customer and customer satisfaction.
Right.
Okay. Defect definition will be like the one like I mentioned earlier. On-time delivery was 86%. Our target was 93%. We fell by 7%.
Right.
Okay. The goal. So expected savings and benefit that can be. It could be okay by improving on-time delivery to meet our annual target. We expect to have savings of $3.2 million.
Right.
And improve our customer satisfaction and on-time delivery to our customer by 4%.
Right.
Okay, so what about the goal statement? That right there would be so it could be basically saying goal statement is to improve the current 86% on-time delivery to meet and or exceed the 94% target, annual target.
By which month, which quarter?
Oh, okay, I see. By the second quarter.
Right. So that should be clear.
Okay. So what and why, or what and when rather.
Right.
Okay. The process start point would be basically beginning of second quarter. Process end point end of second quarter.
No, no. Process start point is nothing but if we are seeing on-time delivery, right, from your suppliers. Is that what you're trying to improve? Then what is the start point? Placing an order with supplier is the start of the process. End process is when we receive.
Okay. Okay. I got
Okay. So there are different things. So like you said, you send it, then you have an order confirmation process.
Sure.
Then you have a what else you have? I mean,
yeah, just receiving a goods receipt. So the process start would be launching RFQ, if you will, or placing order, and then process endpoint is delivery.
Absolutely. So your SIPOC will be within that scope. That's the.
Oh, I see. Okay, so
Now
no,
you
so
got it.
basically, so it shouldn't. So I'm sorry. The process start point is not RFQ. Then I understand now. It's very project scope definition. So it should be placing order is the initiation of placing order, and then process endpoint is receiving of goods.
Absolutely, yeah. So we are only talking about improving the on-time delivery from supplier. So RFQ is not into scope.
Right, I got it. Understood.
So out of scope, you can actually mention those. In scope, we can clearly say, what are we doing?
Mm-hmm.
Okay. And then, okay, so then we go to the SIPOC. And resourcing part you understood, right? Raj, can you explain?
Yeah, it's a process map here with the legend, and it's basically for top level view to understand from the project phase and who is responsible of what, and basically this will be your legend. So and you can share this with the top level stakeholders. So basically, whenever a situation arises, we have it documented as to who is going to do what and why.
Right.
Not why, but who's going to do what, who's accountable for what, who's responsible for what.
Right. Now, SIPOC standpoint, can you list me this? Okay, first you tell me, can you explain what are your inputs for this particular process that you've defined from starting your order placing to?
So the inputs.
What would be your inputs?
So S would be suppliers, and inputs would be the deliveries. The order placement, the order placement.
Right. So inputs can be anything, the orders, number of orders placed, right? Number of orders placed, or any data that is required to calculate on-time delivery. Those can be the inputs. Who can give you that?
For on-time delivery. Yeah, so number of orders placed, order processing time, how long it takes them to process the order, and their on-time deliveries from their suppliers to my suppliers, uh, operational metrics as to see if they're meeting their it could be even capacity metrics, production capacity metrics, and also internal operational metrics to see if they're completing their operations on time or not.
Right.
Okay.
And outputs.
Well, basically, it's the result of the delivery, right? Whether we got it on time or not.
Yeah. So any order that is received, right? That's what we will calculate as, consider as an output. So anything that is not received,
Okay.
right? So anything that's received in the system becomes our output, and who receives the benefit of that particular output? It could be the assembly team.
Could be the assembly
Or
team. Yeah, well, first it'll be the assembly team, the operations team, the production line. Then we
right,
received our parts on time, so therefore we can produce on time according to our manufacturing schedule.
right,
And then ultimately will be our customer because we will be able to deliver a final product to our customer on time.
right. So great. So now you understand how we scope a project. Now we understand how to define just the scope of that project into a process map or a SIPOC. And then how do we address a specific problem, or how do we define a specific problem, put a specific goal statement to it, and how do we align the right resources to do that project, and who are the suppliers for those inputs that you are talking about, and what are those outputs, and whom does it reach to, right?
Yeah, did I get the inputs correct?
Yeah. So inputs is basically your so your first step, right, is placing the orders, right? So if you don't place the orders on time, it also can impact your so
Apply.
your process
Yeah.
starts from the time we place, right? Yeah.
Yes.
So so input can be your purchase order, right? Can be your input, or
Mm-hmm.
required to do a place a purchase order can be your input, right?
Okay. Yeah.
Yeah. So that could be one, or
So input could be our sourcing team, how long it takes them to place the PO to our suppliers, and also could be on the other end, the supplier, how long it takes them to receive, process, and
yeah,
confirm the order.
right. So
Okay.
those can be input.
And the process will be the actual delivery.
Yeah, process would be starting from placing the order, receipt of order by the supplier, order confirmation, and then shipping, and
Okay.
receiving updated. It can be anything. So put that into 4 or 5 different steps.
Right. Right. Okay.
So we stick to only that particular process. We are not moving out of the project scope.
Okay. Okay.
All right, I think we're good with the define. Pretty much covered most of the requirements. Do you have any questions that you?
No, I'm okay right now.
Okay, so now you understand the overall Six Sigma, why Six Sigma, from where it started, and what is the voice of the customer, what is voice of the business, what is voice of the process, right? And how do you identify a project? What do you consider as a project? And where is Six Sigma used, right?
Mm-hmm.
Um, and once you identify a project, or you drive down critical to quality. What is critical to quality? For example, what is the ideal metric that you should be focusing in order for you to drive customer satisfaction or whatever? And then converting that critical to quality metric into a business case, problem statement, goal statement, an estimated benefit, and putting a timeline. Then building a team, right? And
Mm-hmm.
once you build a team, you put the right timelines for executing that project, and then once you scope out the project area, you identify the start point, end point, and identify who can give you inputs for you to, what are the inputs for starting from the starting of that process, and what would be the output of that particular process, and who are the key people involved, who are the suppliers and customers, right? So it's about building a story from the time we hear a problem to we define something very clear and crisp so that everybody understands and we communicate it through a proper governance mechanism, right? So that's all Define is all about.
Okay.